Hi everyone, I will present you now the PSL basic syntax. PSL is a framework that is designed to ease the way we are making a scene with SOFA. PSL framework contains several different syntaxes for the same languages. One of the syntax is using JSON, one is using XML. Today during my presentation, I will only present you the syntax for JSON, but everything that I will present you is perfectly compatible with the XML syntax. So let's start. On the right side, I have the classical SOFA started. I have started SOFA using the -e option, which means that each time I am changing the source code that is on the left side, the scene will be updated. And I have loaded very simple an empty scene which is called start there.psl, which is the PSL extension for JSON file. And I will load this file into SOFA, and of course we have a small warning which say that the file does not contain any valid content. So let's add some valid content, which means a basic root node, and give a name to this node. Okay, and we can see now that the scene has been updated. If you know QML, you will see the two languages are really close. If you want to make a comment, you can make a comment like that. Or like that. Let's add now some more nodes. And to this node we will add an object, which is an OGL model. An OGL model, if you don't know, is a visual representation of an object. And if I save the file, we can see that the OGL model is added, but as we didn't provide any file, nothing happens. So let's now specify the file name. And I think I have an OGL model somewhere on my laptop. It's here, and it's into the mesh directory, I think. Yep. We can also change some of the parameter of the object using the classical SOFA syntax. Okay. And now we can add other of these guys to make a scene. You can see that we have a syntax coloring. The file is provided into the PSL directory, and it works with Qt Creator and Kate editor. So now we have the three child object, but some of them they have the same color and they are at the same position, so it's not very easy to locate them. So let's change the color, and also let's change their position. Something like that, and this will be at the default position, and this one will be on the right. And now you have a very good looking Bulgarian flag you can enjoy. What can I say more? Oh yes, currently this scene is very equivalent to what you could have written using the scene languages, the one that we are using in SOFA for years. And this languages is totally static, and that's why a lot of persons are now using Python to describe scene, to have more dynamicity. With PSL, if you want to make a dynamicity, this is totally possible. because you can type a Python fragment into the language, into your scene, and you do that this way. So I will make first a very simple print something statement, and yeah, we can see that it appears here. Can replace. It's here. And this is where the interesting things start. The first thing you have to notice is that, for example, the Python fragment is into your scene here, which means that when you want to save the file, the fragment will be saved. And this is a very big difference compared to writing scene with Python, because when you write a scene with Python and you save it, you will have the result of the Python execution into your saved file, while with PSL you will have your initial file. For example, if you add this a range loop in which you are adding elements to the root node, what will be saved will not be these guys, because they are the production of the script. It will be the source that generates these guys. You may have noticed something strange. Here I use the self keyword, and this was added to the root node. The reason is that this kind of Python fragment are within the scoping of the curly brace. Let me explain. Here, for example, here we have the opening brace and the closing brace, and so if I make a Python fragment here that print the name of the self object, this will return child1. Self is child1. So this means that there is a hierarchical scoping of variables, which is really practical, because this does not only include the self keyword, because you could also write things like from here child1, or you can do, for example, to be more explicit, you can, for example, have a loop here. One will create something, a child, into the self keyword, and one will create a child to the my name is root object, which is the root of the hierarchy. Here we can see that this happened as we expected. So we have the initial 10 first created by this loop. Actually I can remove it because, yep. And then we have the into the child1 node we have 10 subchild which are created by this line, and we also have added to the parent node by directly using its name these entities. So the scoping is really nice to play with the scene. Okay, so now what we may want to do, for example, is to make a more complex object. So I just remove all that to have just a fresh object. Oops. What happened? Oh yes, I use black color, which is not very good to make things appear. Okay, so let's now transform this visual model into a mechanical one, which is very classical into sofa. Oops, it's not this. And we have some error message here. When you have this syntax, means that there is some problem to create the object, which is very practical. We cannot create because uniform because there is probably no mechanical model, and currently it's a bit annoying because we are relying on the sofa error messages for some aspect, and some of them are not really clear. Okay, so now I have added a mechanical model. My uniform mass object can be properly initialized. What can I add? Yeah, let's connect that with a regular grid topology. Regular grid topology, you need to specify the number of dimension, the min and max position. Okay, and we currently don't have a mapping that connect the visual representation with the mechanical one, so we will do that like that. Okay. What I'm doing is really classical if you are used to sofa, and so there is no real originality currently, except that you have a good syntax. Oh yes, something that may be interesting for you is that if you do some misspelling here, like I did here, you have the message that appear, and the system is capable of making suggestion to fix. So probably you mean barycentric mapping and not barycentric mapping. So let's fix that. So this suggestion mechanism is quite nice, I think. Okay, so barycentric mapping needs the inputs and output, where it goes, the data, this way. I probably forgot something else, yes, it's still because mapping requires 2p. What else? Visual, and I didn't give a name to this guy. Yep. Yeah. So now the barycentric mapping has been initialized, and we can say that we have connection between these two objects. Yep. Okay. In SOFA you need to type a lot of things if you want to make a very simple object, and if you and something really inconvenient when writing scene with SOFA is that you have to all the time cut and paste things all along. Cut and paste things. And so we have implemented a template into PSL to solve this issue. So that when you are happy with an object, you can just transform it as a template, like that. And a template as a name. Let's call this one Armadillo. And I have saved the file, and everything disappeared. But now something appeared, which is template Armadillo. If you look at that, you can see that we have stored all the source code to generate the Armadillo, but there is no instance of this template. And so now, once you have created this template, you can just create an instance of the Armadillo object. And of course, the nice thing is that if you have a look at the armadillo object, into the PSL bracket here, there is a trace that this is an instance of armadillo, and so each time we will save the file, the instance will not be it will be saved as calling an instance and not the sub-element of the object. Of course, you can have multiple of them, which is really practical. Templates are really nice, but what we would like to add now is, for example, some variation. Let's see how we can do that. With template, you can add what we call properties, and properties are arguments to the template. So, for example, you can say I want a name properties and I want a position properties. And okay, and we will change the position. What we want is that the name, and in order to get the value of the name properties, we will use this syntax, which means query Python to get the value of the name variables. And in the same way, the mechanical object, we will apply the translation, but with the value from the position variables. And I think this is enough to have translation. If we do nothing, okay, we are using the default value, but now we can also do this kind of things. A name, John. And its position will be -500. Yeah, it's working, and you can see that the first object is called John. And this template will really save you a lot of typing. Bob and Jimmy. Here we have our three objects, which are three instances of the same template. What else can I show you? Yeah, let's make a small additional template just for you to understand precisely how it's working. So let's make a new template, and we want a template that will repeat an object in a grid. So and we want that. And here what we will do is that we will use our Python fragment. And we will use our for loop. We want to add that to the self object. Let's start with that. Yeah, of course, if I don't close this, we are going to have trouble. So you can see that I have now a second template, which is grid repeat, but I have not instantiated, so nothing happened. Let's remove this guy just to accelerate a bit more. So now we can write grid repeat, and with that nx equal 3 by 3. And okay, we have it. I forgot to specify a name, and I prefer name to be parameters, so okay. I think you get the point how it works. Something interesting is that you are not obliged to have all your templates into your file, because we also have an import mechanism. So for example, you can import something, and the idea is that when you are satisfied with your armadillo code, you can cut and paste it, and here into a file that I will call my templates, and then import it. For example, you can have a look at the shapes.psl. It's a very simple templates file in which that describe cubes and spheres and this kind of stuff. Oops, sorry. And for example, let's import it. So we are imported the shapes. You can see that when you import shapes, you have a new tag into your thin graph, and if you have a look at that, it will say which template this file is providing. You have to it's important to understand that currently it's the classical run so far, so there is absolutely no support from the GUI on the languages, and if one day we one of the target I should say is now to increase the support of PSL into the GUIs, and I think some really great things could happen. But anyway, let's start with, we have our shapes here, and we have our grid repetition thing, and now what we would like is that to have the grid to repeat the shape, but the shape is a template. So first we will need to say which object we want to repeat, and let's write it this way, and here it's a bit different. We will use the instantiate syntax, and where we provide the name of the object we want to instantiate. Something goes wrong. Yes, I forgot, because by default the Python fragments are not importing automatically the instantiate function. It's in PSL engine. You need to import it, instantiate. Something else is not working. Yeah, but it's normal. It's saying that there is no known object, obviously. So now what we want to do is to repeat in a grid something, and this something is in fact shapes.sphere object. Here it is, and currently you have noticed that we have not set the position. Let me explain. If you comment that, and just instantiate the shapes sphere object, it's always at the 0 position, and so basically you need to specify the position like that. Oops. Like this. And when you want to pass parameter to template instantiation using the in Python script, it's very easy. You just have to write it this way. Yep. Minus I O I G O, let's say, and it should be enough. Let's uncomment that. So it's working. Of course, the spacing is not very good, so we can increase it, which makes things much good looking. And so, of course, we can now have our So this is a really powerful framework. Each time you are happy with a template, you just move it into your into a separated file. So here, for example, I will move it to the my templates. So it will be part of my libraries. And if I want to import it, import my templates. I just have to prefix that object. So it's really practical way of making things and composing complex objects, complex scene elements, transforming the scene graph, while still being capable of saving everything. What else can I show you? Yes, we also have an alias mechanism. I don't know if you are aware, but in SOFA, for example, there is a lot of aliases, and some of them are really can be really annoying. Let me see if I can find some. Yeah, for example, collision pipeline is an alias in SOFA, and PSL will warn you about that. It will say that basically you have to use the real name and not the alias to make things clear for people that read the scene what the object is. But alias are quite convenient, so you can define your own, and this is totally different compared to the hard-coded alias in the SOFA source code, because with the custom alias, it's part of the scene, and so everyone that read the scene know which name you give to which object. So the syntax for aliasing is this one, and maybe it will change because here is the real object and here's my alias object. Oh no, my own name. My own name. Oh, something goes wrong. Let's see what's wrong. Oh yes. This is because aliasing is using the using syntax and not the alias one. So when you are, maybe this will be changed because I often make mistakes, and so you can see now that my own name here, each time you use your alias, this is the real object that has been used. It's also let me think if there is other element to show you. No. Yeah, if you have a look at the this may be useful. If you like to edit your object or your scene into the graphical user interface, the attributes, the template properties, you can change them here under the panel live properties. Each of the properties is exposed here, and you can change that and no problem, it will be saved in the right way. Yeah, I think that's all for the basic aspect of PSL. There is much more to say. For example, there is an XML syntax, and this XML syntax is totally compatible with the existing thin file, or not totally compatible, but strongly compatible with the XML syntax, but you still have all the advantages of import, aliasing, templating, and all Python, embedded Python. So it's really good if you are really you don't want to lose all your files and want to reuse that into PSL context. What else can we just say? Oh, it's possible that to mix a PSL file and PSLX, so the XML version of that, so you can import whatever kind of file you want. And something which is also interesting is that you can also write a template in using Python. I think this will be for a future presentation, but just let me show you some example so that you can see how it look like. So here it's no, sorry, here it's no, not working. Why not? Yeah, okay. So here is two templates defined. They are completely written in Python, and they are exported, and PSL can import them as any other file. Let me show you how it looks. I don't understand why it's not working. The drag and drop. Okay, so here you can see I have a theme, and I am importing the Python code and just create the template by calling the Python function. We also have something that is quite cool also, which is the Python. We have a different syntax. You can use decorator to transform a classical Python function into a PSL template. What else? We also have a very interesting DSL. Here it's just a very simple example in which you can replace the classical create node and create object with string with first class object, which are node mechanical object. So it really simplified writing scene in pure Python also, and this is into PSL.tsl packages. So I hope you enjoyed this presentation. I'm sorry for the quality of everything, and I did my best to make things clear. So thanks for your attention, and see you